Good afternoon, everyone. Our talk is today to cover prebiotics and probiotics in preterm infants. So we'll just take you through the important milestones and the current status over the next half an hour or so. Okay, so this is where we'll start the discussion, but first with the human milk oligosaccharides. I think everyone who is involved in neonatal intensive care and even in pediatrics as such, they are very well aware of the importance of human milk oligosaccharides. These are the complex sugars available in the mother's milk as such. They are complex carbohydrates, and they are the third most abundant solid component after lactose and lipids as such. The basic structure of a HMO is basically a single glucose molecule at the reducing end attached to galactose, and together that forms a lactose core as such. We know that till date, almost like 230 very unique, structurally different HMOs have been identified, and they go in size anywhere from 3 to about 32 sugars as such. In terms of their structure overall, you could call them either neutral or acidic. Neutral, there are two types. Fucosylated oligosaccharides is one, and non-fucosylated neutral oligosaccharides, the second class. In silated acidic human milk oligosaccharides, the interest is more because sialic acid is very important in the development and maturation of the brain as such. Good to see that breast milk has 80% neutral HMOs, and that reminds us of the famous 80-20 rule as such, that don't neglect anything which is the 20%, it could be more important. And this is where, remember that 80% are neutral, but the 20% silated acidic HMOs are equally important for the development of the brain. 2-fucosyl lactose, abbreviated as 2FL, and lactose and neotetroids, slightly complicated to remember, are the most abundant HMOs in the milk. Fortunately, 2FL, 3FL, and when it comes to silated acidic HMOs, 3SL and 6SL have been manufactured in the laboratory close to the natural structure as such. So the research is going to expand more on 2FL, 3FL, 3SL, and 6SL. So we need to keep a track of that. Everyone of neonatal team and the pediatric knows that the amount and the diversity of human milk oligosaccharide changes significantly as per the stage of lactation, the infant gestation at birth, from mother to mother, baby to baby, and importantly, from country to country based on ethnicity as such. Good thing to know that the maximum concentration of HMOs is in the colostrum. So that's the reason so much literature currently is devoted to the importance of administering colostrum to the baby as soon as possible. And the previous speakers have pointed out the importance of early expression of milk. So every effort we need to put in to support lactation. The limit usually is about maximum 6 hours. The reason is quite simple, that by 6 hours, there's a natural trigger so that there's apoptosis of the cells lining the mammary gland. That much is the importance of early emptying. Silated human milk oligosaccharides, I have already told you that they are important for the growth and development of central nervous system as such. They also have an important role in resistance to infectious diseases, particularly those coming from the gut. They help in development and maturation of the immune system. And obviously, they have an effect on the total gut microbiota as such. And by per se, they have a significant combination in terms of inflammatory control in the gut. Most of the time, when we read the literature on prebiotic oligosaccharides as such, what we find is the so-called GOSPHOS, which is basically neutral short-chain galactose oligosaccharide, long-chain phosphate fructose oligosaccharides, and the pectin-derived acidic oligosaccharides as such. More and more manufacturers are putting non-human milk oligosaccharides in the formula, trying to mimic what is available in the breast milk as such. The pectin-derived acidic oligosaccharides can have direct immunomodulatory effect. One of the good papers I put on the slides is 2019 May. This is something quite interesting, that can we tailor the human milk oligosaccharides to the intake, especially of a preterm baby, because we know they are what are missing in many mothers' breast milk, depending on mother's secretor status as such. Unfortunately, the number of clinical trials and the total sample size hasn't reached a critical level as such. So the results so far show that the benefits of oligosaccharides in preventing necrotizing enterocolitis, something that we fear every day at the bedside, are not that clear as such. More important to know, is there a specific human milk oligosaccharide that we can supplement to a preterm baby, knowing the composition of HMOs in the breast milk of that baby's mother as such. So this is something like a designer HMO supplementation based on the mother's milk status of HMO. We also don't know whether single or multiple HMOs given together are more protective as such. This is just like saying where multi-strain probiotics are a bit better compared to single strain. So this field is completely open for research when it comes to human milk oligosaccharides. The challenges are quite clear because the natural structure of the human milk oligosaccharide is so complex that even best of the best scientists in the laboratory find it very difficult to develop them synthetically as such, no matter how sophisticated the current methods are for manufacturing them in the lab as such. Secondly, we don't know what's the optimal level of supplementation, what is the role of HMOs for babies who are on donor human milk as such. One good thing that we know that pasteurization process luckily doesn't hurt the prebiotic oligosaccharides much compared to what they do to probiotics as such. We don't know what are the long-term benefits of supplementing human milk oligosaccharides, synthetic or natural, to a preterm baby as such. And that is the reason this 2021 article covers beautifully the future of tailored approach to oligosaccharide supplementation for preterm human infants as such. This will be more relevant, as I said, because now we have commercially available 2FL, which is the most common human milk oligosaccharide in the breast milk. And apart from that, we have 3FL, 3SL, and 6SL, if you specifically want to target brain development and maturation by the sialic acid-related HMOs as such. This is basically something quite important for us because so far the search for biomarkers for detecting necrotizing enterocolitis have not succeeded at any level at all. So this is where they profile the human milk oligosaccharide content or composition of mother's own milk in a large cohort of preterm infants with necrotizing enterocolitis with matched controls who did not have the illness as such. They did a longitudinal metagenomic sequencing of the stool, and what they found that the concentration of DSLNT, I would not spell it out completely, but what it means is disialyl L-nitrotetroase. You could just say DSLNT. So the concentration of this particular oligosaccharide was significantly lower in the mother's milk, which was received by the infants who developed NEC. And at a threshold level of 241 nanomoles per ml, the sensitivity and specificity for diagnosing NEC was 90%. So that's quite a useful tool to have clinically as such. And at the end of this slide, you can have a look that they did something called the random forest analysis, a complicated term that we use in bioinformatics studies. So basically what it means, if you combine the human milk oligosaccharide composition data with the metagenomic data from the fecal bacteria as such, before the development of NEC, this particular pathway was able to accurately classify infants as healthy or with necrotizing enterocolitis at a level of nearly 88%. So DSLNT levels in the mom's milk basically might be a good future biomarker for early prediction of necrotizing enterocolitis so that the other precautions can be taken to reduce the risk of the illness. We know that when we use the word prebiotics, what we mean is synthetically developed human milk oligosaccharides in the lab. Basically, they are just a substrate that is selectively used by the bacteria in the baby's gut, giving them a proper benefit as such. So when they are naturally present in the milk, we know they are called as HMOs. When you develop them in the lab, they are usually called as prebiotics as such. But the mechanisms of benefit of prebiotics are similar to HMOs as such. They will promote the survival and growth of good bacteria inside the gut. Per se, they can block the receptor sites so that pathogens cannot come and locate that as such. And they have direct effect, which are anti-inflammatory and anti-infective as such. 22 is not much, because what we know that to change clinical practice in a randomized control trial, basically you need at least few thousand participants. Those kind of randomized control trials are very rare in neonatal medicine. They require a huge multi-center, multinational effort, and the time from concept to publication is minimum 5 to 7 years. And we know by practice that yes, implementation of RCT findings in clinical practice can take anywhere between 2 to 4 years for simple interventions, and the minimum can it take basically on a public health scale for complex intervention. The average age when it can be implemented in the community, you'll be shocked to know, is 17 years as such, could go up to 26 years. So implementation science is more important, as important basically as RCTs conduct and reporting as well. Most of the prebiotics in the literature are inulin, lactulose, galactose and fructose oligosaccharides, and the pectin-derived acidic oligosaccharides. You could see that prebiotics significantly reduce late onset hospital-acquired sepsis, all-cause mortality, length of stay, time to full feed. But they had no significant effect on NEC because the confidence interval contains 1.44, and obviously some vague entity like feeding intolerance. Now, depending on whether you like systematic reviews or not, you can interpret the findings of NEC by simply saying sample size is not adequate to know the effect of NEC. Optimistic people will say, yes, I can see that 1.44 in the bracket, but overall it says that I cannot rule out there's a significant benefit, possible benefit of prebiotic on prevention of NEC as such. So that's the current state of affair in terms of systematic review of prebiotic RCTs. If you talk about prebiotics, next obvious logical step is symbiotics, because we know most of the animal studies have confirmed that prebiotics, when you combine them with pro, effectively it's a symbiotic product as such. So it improves the survival, multiplication, and hopefully the benefits of probiotics combined with prebiotics. Hardly any sample size, just 6 randomized control trials. You could see that even in the 6th trial, the median sample size is only 200. So basically, it is hardly any significant data for us to say what are the effects of symbiotics at NEC, but this is what the data is, that basically they reduce the risk of NEC, all-cause mortality, late onset sepsis, again it hit 1.21, so can't comment on any significant benefits as such. Important is to know what's on the extreme right side of the screen, what is the level of certainty. And because the sample size is low, obviously the confidence intervals are wide. So that's the reason our estimates are either low level of certainty or very low, especially when it comes to late onset sepsis as such. So overall, symbiotics basically inadequate evidence in the literature. And this is where we come to the core of the topic today about the so-called probiotics for preterm infant. So this topic has become as boring or as exciting as the so-called patent ductus arteriosus. The topic just doesn't close because the controversies continue. The top controversies is in the top, that believers who say that probiotics effect are strain specific. It means all the meta-analysis so far are completely invalid. Every strain needs to have a large randomized controlled trial of at least few thousand. But 2018 is a landmark publication from a group of probiotic basic scientists, what they have shown, and with scientific data, that consistently the fact that randomized controlled trials and routine use studies have shown benefits of probiotics on all the grounds like NEC, sepsis, all-cause mortality, time to full feeds. Basically, it means there has to be some consistent positive beneficial effect that all the common probiotic strains share. This is the landmark paper by Marianne Sanders, the president of the International Association of Probiotics and Prebiotics. It came up in 2018. Most of the clinicians, I think probably they have missed, because as a busy clinicians, we don't read these kind of journals as such. So do take a point that read that article where they clearly say that probiotics bacteria, if you select them from common genus like Bifidobacterium and lactobacillus, they share many, many positive, beneficial modes of benefit together. To give you a sample effect that all of them can liberate short chain fatty acids, all of them can have mucus binding proteins, which will help in adhering of the probiotic bacteria to the gut. Most of them are known to have common cell wall lipoticoic acid. They share at least 9 more mechanisms of benefit. So basically what it simply means that the obsession that probiotic effects are strain specific is now almost null and valid. It means all meta-analyses are absolutely valid. It is okay to combine the data of lactobacilli and bifidobacterium because they share many shared pathways as such. The ghost of the PIPS trial still haunts the people from UK, so we will leave it to them what they want to do. But it is good to see that there are at least 5 or 6 publications from their own side that they show that we should be adopting probiotics for benefit of preterm infants now. People used to say that there's not enough data on babies less than 28 or less than 1 kilo. Now we have data at least close to 4,000 babies from routine use as such, and at least 1,800 to 2,000 babies in randomized control trial. Some people used to worry about probiotic sepsis and product contamination. We have clearly shown in a comprehensive systematic review that till this date, none of the non-RCTs and none of the randomized control trials have shown that this is a significant issue at all. There are only case reports and case series. Only 2 of those babies out of 32 cases of probiotic sepsis died, but they had significant comorbidity, including pre-existing congestive cardiac defect and a gut anomaly. Some people say that our baseline risk of NEC is low and most of our infants are fed breast milk. Now, this is not the correct argument against probiotics because data from Australia has shown, because the country has been lucky that the incidence of probiotics has always been, NEC has always been between 4 to 6% for many years, and now it has gone down further. Preterm trials confirm that quite nicely in the RCT. People who worry about the long-term effects of probiotics, we know that yes, they don't do any harm. If at all, they might give you short-term benefits as such.
Excuse me,
clinically proven.
Slides are not showing, sir. It's not changing.
I'm just on the same slide.
Okay. Yes.
I'm just covering those 9 slides for you so that I don't have to go through those points again.
Okay. Sorry, sir.
Yep. So I'm on second bullet from the bottom line, that those who claim that clinically proven drug quality products are not available should take notice that there are at least 7 products available out in the market: LGG, Lactobacillus reuteri, Bifidobacterium brevi, and then the products like from Lin et al., Flora Baby from Canada. So there are at least 5 to 7 good quality products available in the market. For people is to say that there is a definite need for conducting a trial in babies less than 1 kilo in North America. That argument went out years ago, so that's not to worry about. So this is what we published quite recently, in fact, just February this year. Long-term effects of probiotics on growth, neurodevelopment, and sepsis. Overall, what we show that probiotics can have short-term weight gain, but there was no effect, either benefit or harm, on head circumference, length, and long-term neurodevelopmental growth and Bailey scores as such. You can take a note that in the bracket I have shown that this is based on 30 randomized controlled trials out of the 63 available. So it is quite possible that probiotics might show a long-term effect, positive effect on neurodevelopment and growth, but unless people report on those issues, we will never know. At the bottom, I have covered the issue of probiotic sepsis, and I have shown you only 1 non-RCT showed 1 issue of probiotic sepsis, nothing from RCTs, rest of them are case reports. So the conclusion was probiotic sepsis is a relatively uncommon event, and the benefits rule out the so-called harm. These are the 30 studies from 18 different countries, 77,000 in that meta-analysis, and we have shown that yes, even in routine use, probiotics have the same effect on NEC, late onset sepsis, and all-cause mortalities. Those p-values are once in a while that you will see in clinical research. Importantly, this is the data that shows nearly 4,900 babies less than 1 kilo with significant, nearly 50% reduction in NEC, So that means the argument that there's not enough data in babies less than a kilo is not valid anymore. You can look at the p-values. It corresponds to exactly what the p-value is in RCTs and even in bigger babies more than a kilo as such. It confirmed that the suggestion is multi-strain probiotics are probably better than single strain. So this is the argument nearly 3 years ago that all at-risk babies should be receiving probiotics, probably a mixture. And as I said, based on the famous paper, Shared Mechanisms of Probiotic Taxa in 2018, if you want to use, it is good to use a combination of lacto and bifidobacterium species. And that's what I think one of our senior colleagues pointed out, that clinicians definitely need a guidance on where to find a reliable, safe source of probiotic. That is where national guidelines are very important, like we have in Australia and New Zealand. This is something good to know from the US itself. There was so much of, I would not say criticism as such, but too much of anxiety on part of those from that part of the world. So this is something good to know in JAMA Pediatrics 2021 August. Basically, if you're a non-believer, in the context of the huge data that is available, what are my options? So these authors have very nicely summarized that you have only two options. Either you could stay as a purist and await the results of a so-called adequately powered trial, which will have 80,000 babies who are preterm, very low birth weight, and to confirm that the probiotics don't work. Now, that's not going to happen in life based on the current data. So what are the other options? The second option is simple. Accept the uncertainty of current evidence and start using probiotics. This is what in clinical medicine, what we call as learning to be comfortable with what is uncomfortable. So this is the nice conclusion of the current data as such. This is something very important, especially for all the countries where all the resources are slightly restricted. Probiotics cannot do a magic on their own. So what are the optimal conditions to get the best out of probiotics? In utero transfer of high-risk infant, antenatal glucocorticoids, early preferential use of own mother's milk, avoid formula as much as you could, have donor milk as backup, use standardized feeding protocol, antibiotic stewardship, stay away from unnecessary prolonged exposure to antacid, look at high osmotic load from milk additives and drugs, and on the rounds every day, you have to make a conscious effort to have optimal nutrition versus zero tolerance for necrotizing enterocolitis. That's the balance that you should be trying to achieve every day on the rounds. This is what we have achieved since 2003 in our own unit. You can see that incidence of definite NEC in babies less than 28 weeks now in our nursery is not even 2%. So that is something that we have achieved by implementing all those strategies as before in this slide. If you don't like prebiotics, probiotics, symbiotics, you have a choice of postbiotics. So what are postbiotics? They are the products coming from probiotic strains, short-chain fatty acids, fractions of the bacteria, functional proteins of the bacteria, secreted polysaccharides from the probiotic bacteria, lysates coming from the cell wall teichoic acids as such, and even the pili-type structures on the surface of the probiotic that usually lactobacillus have. So these are the things from the probiotic bacteria that you can use as postbiotics. Advantage is quite simple because you're not dealing with a live bacteria. There's no risk of translocation, antibiotic resistance, and probiotic sepsis. Storage is not a problem. You don't need cold chain. Cost goes down. So overall, it is quite a good thing to use, especially where you don't have other resources to optimize your strategies to improve milk intake and reduce the risk of NEC. And there is some data that shows that if you combine postbiotic with probiotics, the efficiency could go up. If you get fed up with all the biotics, this is one of the ways that you could use out of desperation. This is from US itself, 2017. They were fed up of a very high risk of NEC in their babies less than a kilo. So they went for standardized, extremely slow feeding protocol, nothing for the first 10 to 12 days, and increased feeds at less than 10 ml per kilo per day. And they managed to reduce the risk of NEC from 16.2% to 1.1%. Surgical NEC, zero. NEC versus death, you could see nearly 30% cut down to 7.6. And importantly, no risk in late onset sepsis, higher discharge weight, lower extrauterine growth retardation, and comparable length of stay. So this is one of the options, as you could say, basically no biotics at all. So I think that's where I'll take a break and happy to take any questions. Thank you for having me.